Hello. Why can't you hear a pterodactyl go to the bathroom? Because the P is silent. Ha, ha, ha. All right, we are going to get into it. Today, we are going to look at further sketching for parabolas, i.e. Quadratics, anything where x squared is the highest power there. Okay, it's going to give some sort of parabola. And basically, what we're trying to get at is quadratics with a perfect square or something factorized. They can be used to easily sketch just by understanding some simple transformations. So understanding those transformations, I'm going to go through some of these. Okay, the first of all, the most common one is you're going to have this parabola and it's going to cut through your origin 0, 0. Now, if I have that x squared and I plus it by 1 and the plus 1 is on the outside, that's just going to shift my whole parabola up 1. Okay. Does that transformation make sense? It just goes up 1. If I'm looking at this one down here, I've got a negative x squared, so that's actually going to push it down this way. But that minus 1 is actually going to drag it down 1. So that means it gets moved down 1 because the minus 1 is on the outside. It drags the whole thing down. So that's going to be minus 1. That's my parabola. Okay. Now, this is where we start to get into the perfect squares. Now, if I have the minus 1 or a plus 1 or anything within the bracket, it's no longer an up and down shift. It actually moves it left and right. So in this case here, that minus 1 is actually going to shift me 1 towards the right. Okay. So that there comes my new parabola. A minus will shift to the right and the plus will actually shift to the left. Okay. If you want a reason why is just go by your x-intercepts and you'll see that 1 becomes your x-intercept. Okay, letting y equal 0. Continuing on, what if I have x plus 2 squared? That means I actually move 2 to the left. So normally we would cut at 0, 0, but my parabola now moves 2 to the left. And if I was to label that, that would be negative 2. Okay, and if I have a negative x plus 3 squared, that's actually going to move it 3 to the left. And the negative is actually going to flip it from concave up to upside down. Okay, that is minus 3 there. Okay, and for these last two here, what if I have x plus 2 squared and then a minus 1? First of all, it's going to move it 2 to the left. And that minus 1 is actually going to move it down 1. Now, because it is a positive x squared, I know that it's still going to be this guy here. And I can see that my vertex is minus 2, minus 1. Okay, and this last one here, if I have x minus 1 squared, that moves my center 1 to the right. And that plus 2 actually moves it 2 up. So I'm actually going to be there. And that's my parabola. So labeling that, that's 2, that's 1. There's my parabola with my vertex. Okay. Now, sometimes what they'll ask is they'll ask you to complete the square and hence sketch. So let's do this process here. First things first is I'm going to have y equals x squared minus 4x. And to complete the square, I'm going to plus half of that thing squared. And I'm going to have that minus 7 out at the end. Okay, so taking a look at that, if I plus 4, I also need to minus the 4 to kind of offset it. Okay, so to write this out, this becomes x squared minus 4x plus 4. And then I have the minus 7 minus 4. Now, in essence, that just cancels out, but we're not going to do that because we need it to complete the square. So that becomes x minus 2 squared, that section there. And then I'm left with a minus 11. Okay, now if I have this as my new kind of adapted, completed the square version, I can see that sketching this is going to be somewhat easy. I would see here that, okay, my center, which was at 0, now moves right 2 spaces because of that -2. And I'm going to move down 11. Now, can't really move down 11, but I'm just going to pretend that I can. And I'm going to draw something that looks like this. That should be close enough for me as long as I label that this is -11 and that's 2. That will be enough to get me some marks. Okay. And then just for reference sake, I'm pretty sure that should be -7. Using my letting x equal 0 to find my y-intercept. Okay. Now moving on, you also know a couple of things about the quadratic formula and the graph. I've put the quadratic formula up there for you. And just remembering that it needs to be in the form of ax squared plus bx plus c. So a is always the coefficient of the x squared, b is always the coefficient of the x, and c is always the constant. Okay. And this is just a brief recap as well. You have the axis of symmetry, which is x equals minus b on 2a. You kind of see that comes from your formula. Okay, right there. And then your vertex is when you plug that x value into your original function. Now we're going to take a brief look at this thing called the discriminant. And this discriminant is the thing that is under the square root. So that's going to be b squared minus 4ac. Okay. And you can see that I've written that double again there. And it's just the thing under the square root. What this tells us is it tells us how many roots or zeros or x-intercepts a graph has. Okay, now these words roots, zeros, and x-intercepts, they're all interchangeable. A root means a zero means an x-intercept means a root, same thing. Okay, now this is what I mean. If I'm talking about x-intercepts, I'm going to try to highlight these in maybe yellow. You can see that in this first one, can you see how this blue parabola has 2 x-intercepts and this red one has 2 intercepts? Okay, so we call them 2 x-intercepts, 2 real roots, 2 distinct roots. And all this is telling us about the discriminant is actually going to be greater than 0. Okay, now if I look at these next two, and I drew 2 just to kind of give you an idea whether it's positive or negative, it kind of works. Now, can you see how for both of these parabolas, there's only one x-intercept? Okay, it only touches once. Okay, so this is what we call one x-intercept, or sometimes we call it a perfect square, which we kind of saw before. And sometimes we'll call it one real root or one distinct zero, all those kinds of things. If that's the case, then what we really have is we have our discriminant equaling 0. Okay, now this last one, if you take a look here, there's no x-intercepts. Okay, there's none. It will not touch my x-axis. So we say there's no roots. We say that the parabolas are positive or negative definite, which just means they're definitely all positive or definitely all negative. So this is the definite positive up here. And down there is the definite negative. Okay. Now, for this to be the case, the discriminant will actually be less than 0. Okay, and that's kind of how you would apply it. Now, what they'll say is how many roots does this equation 50x squared take away 200x plus 200x have? The way that I would do this is if I see the word roots, I'm going to see what my discriminant is. It's going to equal to b squared minus 4ac. Yeah. And it's going to be minus 200 squared. That's b minus 4 times a, which is 50, times c, which is 200. And I see what that number is. 200 squared should be 40,000. Yeah. And then the other one will be take away another 40,000, I think. Looking at that. So it's going to equal to 0. Now, if my discriminant equals to 0, what did we say about that? It means that it's a perfect square. Or in other words, there's 1, 0, slash root. Okay. Now, we could have done this another way. I could have factorized this. I could have said fx equals to 50 outside of x squared minus 4x plus 4. And I could have seen here that this was the same thing as 50 bracket x take away 2 all squared. Okay, that is a perfect square. And so from here, I can see immediately that there's only going to be one root. Okay, now not all your questions will be clean like this. And so sometimes your discriminant comes in handy, especially when you're looking for how many solutions. Okay, that's it. I'll catch you guys later and bye-bye.